Here we go with 1.E.2 homework. It's 4.78, 4.80, 4.86, and 4.92 from the back of the chapter 4 in Chang. 4.78 says a sample of 0.6760 grams of an unknown compound containing barium ions, Ba+2, is dissolved in water and treated with an excess of sodium sulfate. If the mass of the barium sulfate precipitate formed is 0.4105 grams, what is the percent by mass of barium in the original unknown compound? So this is a classic gravimetric analysis question. We need a net ionic equation. Barium plus 2 plus SO4 minus 2 makes barium sulfate, which precipitates. Now we know the mass of the precipitate, which we need to change to moles. .4105 grams times 1 mole over 233.39 grams. That's going to equal 0.001759 moles. Barium sulfate, realizing from the net ionic equation that a mole of barium sulfate originates as a mole of barium plus 2. We see that we have 0.001759 moles of barium plus 2. Changing that to grams. Molar mass of barium is 137.33 grams. I get 0.2416 grams of barium. The original mass of the compound is 0.6760. Part over the whole, 0.2416 grams of barium over 0.6760 grams of compound gives me a percent of 35.74. Okay, moving on to the next problem, 4.80. The concentration of copper plus 2 ions in the water, which also contains sulfate ions, discharged from a certain industrial plant is determined by adding excess sodium sulfide Na2S solution to 0.800 liters of the water. The molecular equation is Na2S plus CuSO4 makes Na2SO4, all of those aqueous, plus CuS solid. Write the net ionic equation and calculate the molar concentration of copper plus 2 in the water sample if 0.0177 grams of solid CuS is formed. So now we're in 4.80. The net ionic equation is between copper plus 2 and S minus 2 to make CuS. We have 0.0177 grams of CuS. CuS has a molar mass of 95.61 grams. So that's 0.000185 moles. For every mole of CuS, started with a mole of copper 2 ion. And so the molar concentration in the original sample is the moles divided by the liters. It said the liters was 0.800. Final answer, 0.000231 molar Cu plus 2. 4.86 is our next question. It says calculate the concentration in molarity of an NaOH solution if 25.0 milliliters of the solution are needed to neutralize 17.4 milliliters of a 0.312 molar HCl solution. Classic acid-base titration problem, which we solve with the ECMS approach. We have NaOH reacting with HCl to make NaCl plus water. We had 0.0174 liters and a molarity of 0.312. So molarity times liters equals moles. 0.000543 moles of the titrant, NaOH, the standard solution, the one we know the molarity of. Using the mole ratio, 0.00. Okay, that's my bad. That's not NaOH, that's HCl. HCl is our titrant. NaOH is our analyte. I'm sorry on that one. 0.00543, not 3 zeros. Okay, get those things fixed. 0.00543 moles of HCl times 1 mole NaOH for every mole of HCl means 0.00543 moles NaOH must have been in the analyte. Now to find its molarity, I need to divide its moles by its liters. 0.00543 moles divided by 0.0250 liters equals 0.217 molarity NaOH. Final answer. Now, 4.92. The SO2 present in air is mainly responsible for the acid rain phenomenon. Its concentration can be determined by titrating against a standard permanganate solution as follows. 5 SO2 plus 2 MnO4 minus yield plus 2 waters yield 5 SO4 minus 2 plus 2 Mn plus 2 plus 4H plus. Calculate the number of grams of SO2 in a sample of the air if 7.37 milliliters of 0.00800 molar KMnO4 solution are required for the titration. Here we have 5 SO2 plus 2 MnO4 minus plus 2 waters yields 5 SO4 minus 2 plus 2 Mn plus 2 and 4 H pluses. All right, molarity times liters equals moles. So our KMNO4 has a 0.00800 molar solution. That's our titrant, 0.00737 liters. Makes 5.90 moles, or 5.90 times 10 to the minus 4 moles of KMNO4, potassium permanganate. Now realizing that a mole of potassium permanganate is going to also give you 1 mole of MnO4 minus when it dissolves. So that little trick was I just got rid of the K plus because it's a spectator ion and that doesn't participate in the reaction. So MnO4 minus does. So 5.90 times 10 minus 4 moles of permanganate ion times 5 moles of SO2 for every 2 moles of permanganate. 5:2 ratio gives me 1.48 times 10 to the minus 4 moles of SO2. Changing moles to grams. By multiplying by 64.06 grams over 1 mole gives me 0.00948 grams SO2, final answer. So that's the end of the Big Idea 1 homework. Thank you very much.